Welcome. This is the 311, part 3, final part 3 of 3. And you're actually getting to polynomials, which you'll see in AGS2. And the scenario is there's a rectangular box and you're looking at volume in 3 dimensions, and the width is 2 inches shorter, the height's 8 inches longer. So you can represent this as volume is the product of those 3 dimensions, and it's got to be less than or equal to 96. Now, you can get here once you learn polynomials and how to expand as well as how to divide polynomials. You'll be able to come up with this, but that's really for next year. So these two inequalities are equivalent. So we can solve this inequality, which is comparing to 0, and that will also be the solution to this inequality. When we look at this, there's some things we notice. If it's going to be less than or equal to 0, it's always good to start with the zeros. In this case, if x equals 4, the whole expression is 0. If x equals -4, it's also 0. And if x equals -8, it's also 0. And then here I've plotted those points, -8, -4, and 4 as the x-intercepts. Now, we're trying to find a solution not to the equation, but to the inequality. And the inequality, let's change this from equation back down to inequality, is when it is less than or equal to 0. And one way is to try some numbers. Like if you did -10, this would be negative, negative, negative. So the product of 3 negatives would be a negative. So anything to the left of 8. If it's, say, -6, you would have negative, negative, positive. And when you multiply those together, you get positive. Same thing here. If you try 0, you have negative, positive, positive. And you end up with negative. And the next one you have positive. So you can see the situation is if it's to the left of -8, or if it's between -4 and 4, it will be less than 0. The green represents the graph of a cubic, and it will be less than 0 below the x-axis. So the next one is use solutions to determine the actual dimensions. So we know we could pick from negative here, but that's not going to be the dimension, right? It's not going to work. You can't have a negative dimension. Same thing here. You can't use -4. So the first one we could really try would be 0. Look what happens at 0. 0, -2, 8. This is, you actually end up with 0, but the problem is you can't have a side length 0. So then you can try another one like 1, and 1 minus 2 is -1, and 1 plus, whoops, I didn't mean to do that. 1 plus 8 is 9, and then you get a negative value, which is also not going to work. So far, we have to say no to these possibilities. But there are other ones. What if it's 2? If x is 2, we've got 0, 10, and then again 0. So that's not going to work. Okay, but we could try the next one. If we have 3, we have 3, 1, and 11. And that would be 33, which would be less than. So that is a possibility. We could try, let's get rid of this. We could try 4. So 4, 2, 12, right? And this actually is equal to 96. So this would be the highest possible value where x is equal to 4. We also know that this one, when x is equal to 2, is too low. So therefore, 2 is going to be less than x, which is going to be less than or equal to 4, which we can see on there. The last one is really algebra, and it's looking at what happened in that previous problem to expand from this to this, and it's recognizing these steps. And you know, the first thing that they did here, this is where we started, and this they expanded, right? They multiplied the two binomials together. Then we've got distributive property, right? They distributed the x. And then we used addition. We added negative 96 to both sides. And then here's another distributive property. So they're distributing the x plus 6 to get an equivalent. And then I would call this distributive property also. It's x squared minus 16 times the other expression. And then finally, it was really factoring. We factored the x squared minus 16.